Namaskar. You are again welcome in this class. As in the last class, we have discussed about trigonometric identities, and we were discussing exercise 7.2. So we will continue this session for discussing exercise 7.2. Exercise 7.2, and in this class we will discuss the next part of this exercise, and let us try to complete this exercise today so that we can end this session. Okay, so the question is, next question is question number 5, question number 4. Find the value of given relation. And what is given relation? That is question number 4 and part number 1, and it is given as sine 35 degree, and that is divided by cos 55 degree whole square. Again in the next step we have cos 55 degree, and that is divided by sine 35 degree and whole square also, and minus 2 cos 60. So first we have to solve the given relation so that we can calculate the desired value of this question. Okay, so first you can think that we have discussed, before discussing this exercise we have learned about complementary angles and relations of helping trigonometric ratios for complementary angles. As we know, we can convert sin theta into cos theta by its complementary angle. Again, we can also change cos theta into sin theta by its complementary angle. Okay, so next part is, so we can also change tan theta into cot theta by using helping trigonometric ratios, because we know these are helping trigonometric ratios of each other for complementary angle. And so the next part is for sec and cosec, we have also discussed. Okay, so first we have to think that how we can change sin 35 into cos 55 over cos 55 into sin 35. So first we have to use as the property for sin theta. As how we can write sin theta? As you know, here sin theta is 35 degree, and we have to convert it into cos theta, so that we can change. Here I am writing cos, and I can write 90 degree minus 35 degree, and that is divided by cos 55 degree whole square. The next part is same part we have to change here. Here we can write as cos 55 degree, and that is divided by cos 90 minus 35 degree, as the same part we have written. Okay, and minus 2 into cos 60 is equal to 1 by 2. So in the next part we can solve this. The value of this is cos 55 degree, cos 55 degree, and that is divided by cos 55 degree whole square, and plus here also cos 55 degree, and that is divided by cos 55 degree whole square, and minus 2 into 1, that is equal to 2 into 1 by 2, that is equal to 1. So we can take this so we can see here that cos 55 is cancelled by cos 55, so we are obtaining as 1 square, and in the next step we have also 1 square and minus 1, so we can add 1 plus 1 minus 1, that is 1. The desired answer is 1. You should write down. And the next question of question number 4, part number 2, we have to discuss, as we have to find the value of the given question. And what is the given question? It is given as a sine 27 degree, and that is divided by cos 63 degree whole square again, and plus cos 63 degree, and that is divided by sine 27 degree whole square, as we have to calculate the value of the given question. Okay, so first thing, as how we can calculate the value. First thing is that we have to change each and every function into its helping trigonometric ratio by using complementary angle. As we want to change this sine into cos, as how we can change, first we have to take this is as theta, it means I can see as it is sine theta, and we have to convert it into cos. So how we can change? As we can change cos 90 degree minus 27 degree, and that is divided by cos 63 degree. So we have changed sine into cos here. Again you can see here the same term is given here, but the opposite of the first term is here. So we can again change sine 27 into cos. How we can change? Cos 63 degree, and that is divided by cos of 90 degree minus 63 degree, sorry 27 degree, and whole square again. So we have to solve this as cos, subtract 27 from 90, as we are obtaining 63 degree, and that is divided by cos 63 degree whole square, and plus here also cos 63 degree, and that is divided by cos 63 degree and whole square again. As you can see, both terms are cancelled by each other, so we are obtaining as 1 square plus in 1 square, and we can write as 2. The desired value of this question is 2, as you should write down. Okay, now we will discuss the question number 5, part number first. What is given? Okay, now see question number 5. What is given here? As question number 5 and part number first is given as tan 12 degree, and that is multiplied by cot 38 degree, and that is again multiplied by cot 52 degree, that is multiplied by cot 60 degree, and that is multiplied by cot 78 degree. This is the given question, as we have to find value of this given question. Okay, so first you have to think that take these part together, which has total angle equal to 90 degree. As you can see, here angle is 12 degree, and here is angle is 38 degree, here is 52 degree, here is 60, and here is 78. So we are taking two angles together. The addition of two angles will be 90 degree. So you can see here, if we add 12 degree and plus 78 degree, that is equal to 90 degree. So we are taking as tan 12 degree and cot 78 degree together. The second part is in this question there is some misprint, as it is given as cot 12 degree. So we are taking as here cot 12 degree and cot 78 degree together. The next part is we have to take cot 38 degree into cot 52 degree together, and the next part is cot 60 degree together. Okay, now see, we have to change this one into this, otherwise this part into this. So we are taking this part to change this. So we are obtaining as this is given as cot 12 degree, and we have to change it into helping trigonometric ratio, and we can know as we can write 90 degree minus 12 degree, and that is multiplied by cot 78 degree. This is the part first. Second part, we again solve this part as we can write tan 90 degree minus 38 degree, and that is multiplied by cot 52 degree. In the next part we have cot 60 degree. So you can see here, if we subtract 12 degree from 90 degree, then we will obtain as 78 degree, and is multiplied by cot 78 degree. And we know tan and cot are opposite functions of each other. Here we can write as tan 52 degree, and that is multiplied by cot 52 degree, and again it multiplied by cot 60 degree. So you can see these parts are cancelled, and we are obtaining as 1 here. Again in the next part, these parts are cancelled because of reciprocal property, and we are obtaining as 1, and here the value of cot 60 there, that is degree 1 upon root 3, and we are obtaining as 1 upon root 3. The desired answer of this question, as you should write down. Okay, the next question of the next part of this question is given as second, that is given as tan 5 degree. Okay, now tan 25 degree, now tan 30 degree, now tan 65 degree, and now tan 85 degree. The same part as we have discussed in the last part, as it is given in terms of tan. So first we have to take the two parts together which have the addition of angle is equal to 90 degree. As you can see here, angle is 5 degree and here angle is 85 degree, and the addition of both the angles is equal to 90 degrees. So we are taking both the terms as together. Okay, so here tan 5 degree and is multiplied by tan 85 degree together, we have taken as together. Now the next part is here tan 25 degree and that is multiplied by tan 65 degree. Okay, we have taken these two parts together and the remaining part is tan 30 degree. So now see how we can convert this, as both the parts are given in terms of tan. So one terms we have to change it into its helping trigonometric ratio. So we are going to change this tan 5 degree into its helping trigonometric ratio. As we know, the helping trigonometric ratio of tan is cos. So we are going cot. So we are going to change it into cot, as we can write as 90 degree minus 5 degree. This part we have to take as same as it is tan 85 degree and is multiplied by the same rule is applied here. Okay, so here we are writing as cot 90 degree minus 25 degree and that is multiplied by tan 65 degree and again tan 30 degree. So you can see as if we have solved this, then we will obtain as cot 85 degree and that is multiplied by tan 85 degree into here again cot 65 degree and that is multiplied by tan 65 degree and that is multiplied by tan 30 degree. So you can see these two terms are cancelled by each other, so we are obtaining as 1 here, and these two terms are cancelled by each other, so we are obtaining as 1 here, and here tan 30, and that we know the value of this is at 1 by root 3, so we are obtaining 1 by root 3 again. Okay, write down. Okay, now the next question is question number 6 and that is given as represent the given relation into the trigonometric ratio up to from 0 degree to 0 degree to 45 degree. As we have to convert the given trigonometric ratios into 0 and 0 to 45 degree. So the first relation is given as question number 6 and part is sine 81 degree and that is added by sine of 71 degree. Okay, and the second part is, as we have to write down both the parts together, and second is given as tan 68 degree and plus sec 68 degree. So now see, as we have to change these given angles up to 0 degree to 45 degree. As first you can see that this angle is not coming into this range. So first we have to adjust this range by using complementary angle. As we know, sine can be changed into its helping trigonometric ratio by complementary angles, as we can write 90 degree minus 81 degree. Again, this angle is not coming, this angle is also not coming in this range, so we have to adjust this angle in such a way that the obtained angle will come in this range. As we know, this angle can be changed into complementary angles by using helping trigonometric ratio. The helping trigonometric ratio of sine is cos, and we can write 90 degree minus 71 degree. Okay, the next sum is, as we can solve is, if we are subtracting 81 from 90 degree, then we are obtaining as 9 degree, and plus here again if we are subtracting this one, then we will obtain 19 degree, as this is the desired relation for angle 0 degree to 45 degree. Now again the same part we can discuss as this part, as we can write cot 90 degree minus 68 degree, and this part is written as cosec 90 degree minus 68 degrees. So we can adjust as cot. Okay, now subtract 22 degree. Okay, and plus here cosec 22 degree, as you should write down. This is the desired answer of this question. And the next question is question number 7. What is the given question? As we have to prove that the given relations, prove the given relations and the first part is question number 7, as it is given as the sine 85 degree and plus cos 25 degree, and we have to prove as it is cos 25 degree. And second part is question number 8, and we have to prove as sine 35 degree, and that is multiplied by sine 55 degree, again minus here cos 35 degree, and that is multiplied by cos 55 degree. So we have to prove that is equal to 0. So first we are going to discuss these two questions as we have to prove. So first we will take one side as LHS by taking LHS. And the LHS is given as LHS, that is equal to sine 65 degree and plus cos 25 degree. And first we will change this sine into cos, as you know that cos is the helping trigonometric ratio of sine. So we can change it by using complementary angle, as we can write cos in the place of sine, and here we will write as 90 degree minus 65 degree plus cos 25 degree. The next term is we have to solve as cos 25 degree and plus cos 25 degree, and we know that these two parts can be written as cos 22 into cos 25 degree, that is equal to RHS, hence proved. The question is proved. The next question is given as sine 35 degree, sine 55 degree minus cos 35 degree, cos 55 degree, that is equal to 1. So by taking LHS, and we have LHS that is given as sine 35 degree, and that is multiplied by sine 55 degree minus cos 35 degree and cos 55 degree. So first we will change as either we have to change sine into cos, or we have to change cos into sine. Which part change? As I'm going to explain this question by changing sine into cos. As we know, cos is the helping trigonometric ratio of sine by its complementary angle. So we can write cos in the place of sine by writing as 90 degree minus 35 degree, and here cos 90 degree minus 55 degree. And the remaining part will be written as sine cos 35 degree and is multiplied by cos 55 degree. So in the next part we will solve as cos. Okay, now subtract, and we will obtain as 55 degree here, and here we will obtain as 35 degree. Okay, 9 minus here the remaining part will be same, cos 35 degree and cos 55 degree. As you can see, both parts are the same, so we are subtracting the same value from the same value, and we will obtain as 0. This is RHS, hence proved. So we have solved question 7 and 8. Now we will solve question number 9. Okay, now question number 9 is given as prove that cos 70 degree and that is divided by sine 20 degree. Again in the next step we have cos 59 degree and that is divided by sine 31 degree, and a minus that is subtracted by 8 sine square of 30 degree. So we have to prove that this is equal to 0. This is question number 9. Again we have to discuss as question number 10, and the given question is as sine 90 degree minus theta and cos 90 degree minus theta, and that should be equal to tan theta and that is divided by 1 plus tan square of theta. So now we will discuss these two questions by using the same property. Okay, first see here, as it is given as in terms of sine and cos, and as you know that sine and cos are helping trigonometric ratios of each other. So we will change first part into second part. Okay, and how we can change, as we are going to change this cos into sine by using complementary angles. Okay, now I will write down as here sine A. Okay, and now 90 degree minus 70 degree is written here, and that is divided by the same term as it is given. In the next step we have to change the second part, as we have to change this cos into sine, and here sine 90 degree minus 59 degree that is divided by sine 31 degree, and the remaining part will be same as 8 sine square 30 degree. Now in the next step you can see, if we have solved this step, then we will obtain as 20 degree, and that is divided by sine 20 degree. And the next step we have sine of 51 degree, as we have subtracted 59 degree from 90 degree. Okay, and that is divided by sine 31 degree minus 8 into what is the value of sine 30, and that we know that is equal to 1 by 2 square. Okay, the next step you can see these parts are cancelled, and in the next step these parts are cancelled, so we have obtained 1 and 1 here, and this part is solved as minus 8 into square of 1 that is equal to 1 and square of 2 that is equal to 4. Now 1 plus 1 that is equal to 2 minus 4 is cancelled, so 4 will cancel this 8 by 2 times, so we are obtaining as 2. 2 minus 2 that is equal to 0. The given parts is RHS, HP. The next question is question number 10. So first we have to take one side, as one side is given as by taking LHS, and LHS is given as sine 90 degree minus theta and cos 90 degree minus theta. So what we can write, as you know, sine 90 minus theta can be written as cos theta, and this can be written as sine theta. So this is the LHS. So we will solve again RHS separately. So RHS is given as tan theta, and that is divided by 1 plus tan square of theta. So how we can solve, as you can see here tan theta is written, so we can write as sine theta, and that is divided by cos theta. Again 1 plus sine square theta, and that is divided by cos square theta. As you can see here we can write sine theta, and that is divided by cos theta. Again we have to take LCM in this term, as we can take as cos square theta as LCM. So we have cos square theta and plus sine square of theta. Now we can see as these parts are cancelled, cos square theta. In next step these parts can be written in opposite reciprocal, so we have sine theta, and that is divided by cos theta and multiplied by this term is taken into numerator, and the remaining part will be in denominator. As we know this part is equal to 1, so cos theta's 1 power is cancelled by 1 power, so we are obtaining as sine theta and multiplied by cos theta. This is equation number 1 and this is equation number 2. So we can see that LHS is equal to RHS, hence proved. Okay, now question number 11 and 12 we have to solve. Question number 11 and 12 is given as, question number 11 that is given as cos 90 degree minus theta into cos theta, and that is divided by tan theta, and plus again here given as cos square of 90 degree minus theta, and that should be equal to 1. Okay, and the question number 12, that is given as tan 90 degree minus theta, and is multiplied by cot theta, and it is divided by cosec square theta, and minus cos square theta, and that should be equal to 0. So both of the given questions we have to solve as by using helping trigonometric ratios. So we can write as cos 90 minus theta, and that can be written as sin theta, and is multiplied by cos theta, again divided by tan theta, plus here we can write as sin square theta. So next step we can write this part into sin and cos. So we can write sin into cos theta, and divided by sin theta, that is divided by cos theta. So you can see sin theta can be cancelled by sin theta, and this cos can be taken as numerator. So it is given as, so in the next step we can write cos square theta and plus sin square theta, and that is equal to, we know that is equal to 1, hence proved. The next question we have to solve as tan 90 minus theta, and we can write as cot theta is multiplied by cot theta, and that is divided by cosec square of theta, and minus cos square of theta. Now in the next step we have to convert all the given trigonometric ratios in terms of sine and cos, and you know cos can be written as cos theta, and that is divided by sine theta. Again here cos theta and can be written as divided by sine theta. In the next in denominator we can see there is written as cosec square, and we can write 1 upon sine square of theta. So now minus cos square theta is given as. Now next step is multiply both the functions as we are obtaining cos square theta, and that is divided by sine square theta, and that is divided by 1 upon sine square theta, and minus cos square of theta. As you can see these parts are cancelled, so we have obtained cos square theta minus cos square theta, and that is equal to 0, hence proved. Okay, now okay, so today we have discussed up to question number 12, and I hope you have understood what I have explained to you in the last classes, as it is completed today. For today, we are going to end this session. I hope you have learnt more and more parts of this book as your syllabus part. So I hope you have learnt very much things, as it is very important part of your syllabus. Okay, so with hopes and I can see with very much hard working manners, I hope that you have to learn and you have to study continuously. Okay, thank you.